Westerlund 1, a supercluster with a total mass 100,000 times our Sun.
Westerlund 1 right now holds the world's record for the biggest known young cluster. It has about 100,000 stars, and what's really odd is for a long time we didn't even know it was that massive. Astronomers have known about Westerlund 1 for a long time, but only about 5 years ago did we first get a glimpse of all the stars in the cluster, because that's when we had infrared detectors that could peer through the dust in the galaxy that's situated between the Earth and the cluster.
Recent advances in infrared astronomy revealed a space only 6 light-years across, packed with a thick population of stars. The biggest and brightest are galactic freaks, supergiant stars, in a range of sizes and colors from blue to red and even yellow.
The blue supergiant phase and the yellow and red supergiant phase represent phases during the lifetime of a massive star. They start blue, they become red. In some cases, they go back and forth between blue and red as the outer layers are lifted and we see deeper to the hotter material. In between the red and the blue phases, they're yellow, and so we call them yellow supergiants.
To date, astronomers have discovered only a handful of these extremely massive clusters. And like Westerlund 1, all of them were virtually unknown until very recently.
Just to express how ignorant we are, realize that only 10 years ago, we didn't know about any of these massive clusters. Every young cluster we knew about, more than 10 years ago, all had less than 10,000 stars. We know of thousands of those kinds of smaller clusters. Right now, we only know of a dozen of the massive clusters.
Because our galaxy is so filled with dust, most star clusters discovered so far exist in an area surrounding our particular place in the Milky Way. We can see barely as far as the center of the galaxy. But as technology improves, our view will extend further and further into the more distant spiral arms.
Westerlund 1 won't be the most massive young cluster known for a long time. We're still discovering these other clusters all the time.
A few superclusters are near the galactic core, where the gravitational tides of the Milky Way's giant black hole may rip them apart in just a few million years. For now, though, their massive bright stars are being studied intensely. Similar dangers lurk inside another cluster close to the galactic center. It's called the Arches Cluster, 25,000 light-years from Earth and just 100 light-years from the Milky Way's core.
The Arches Cluster was the first young massive cluster discovered in the galaxy. It is the densest young cluster in the galaxy.
Our own Sun's neighborhood is practically empty compared to the Arches Cluster. In the 50 cubic light-years around the Sun, the only neighbor is the Alpha Centauri system. If we were in the Arches Cluster, the stars are so tightly packed, this same space would contain more than 1 million stars, lighting up the sky of any planet both night and day.
If we lived on a planet surrounding a star in the Arches Cluster or a cluster that's similarly dense, we would see thousands of stars in the night sky. In fact, some of those stars would be so bright that they would individually be much brighter than the full moon. The night sky would be very bright. It would be comparable to the light level in an office during the day.
Our search for cosmic clusters has taken us to the Arches, one of the most important clusters in our galaxy. It's here that scientists discovered just how massive a star can get.
That seems like a simple question, but we didn't know up until a few years ago how massive a star could actually be.
The Arches had everything scientists needed to answer this question. First, in such a big cluster, there were surely many massive stars to study. Second, at roughly 2.5 million years old, the cluster was young enough that its massive stars wouldn't have exploded yet. So the biggest star in the cluster would probably be a good guide for how massive stars can get in the wider universe.
What we saw in the Arches is a collection of many, many low-mass stars, not so many, maybe hundreds of medium-sized stars, and then a dozen or so very massive stars with 130 times the mass of the sun in them. Beyond that, we saw nothing. It was like falling off a cliff. If stars more massive than about 130 solar masses can form and live, then they would have been there in the arches. So apparently, nature has placed a limit on the maximum mass of a star. It's probably somewhere between 130 and 150 solar masses. Because we see that individual stars and globular clusters are very old, in some cases being dated to 13 billion years old, we know that the globulars are that old, and we know that they were formed right at the time when the galaxy was forming. It's still unclear whether the system formed first and then the galaxy condensed out of the remaining molecular cloud, or if they condensed and collapsed and formed at the same time.
For now, most globular clusters remain very crowded. 60,000 times as dense in stars as our own galactic neighborhood. But because the clusters are old, any massive bright stars they once had have long since burned out. The globular cluster sky would be crowded, but its glow would remain subtle.
If we were on a planet around a star in a globular cluster, we would see thousands of stars, but the average illumination at night would be comparable to the illumination you'd experience in a room with some candles lit up.
Orbiting out in the halo, globular clusters are to the galaxy something like moons are to a planet. Globular clusters on the outskirts of other galaxies show that this is something many galaxies have in common.